CodeForces round 126 Div2D. We've been given two arrays A and B of n length each. A is initially all zeros and B is given to us. In one operation, also we are given a integer k in the input. In one operation, we can select a subarray of size k from array A and increment the indices 1 to k in that particular subarray by values 1 to k. So that means that index 1 would be incremented by 1, index 2 would be incremented by 2, and index k would be incremented by k. So the way I thought about this problem was initially what struck me from this problem is that there's only one way to uh, there's only one way to find the number of operations required to make this element valid and number of operations to make the last element valid. Since the first element can be changed only if we only uh, by an operation of the form this, where the starting index of the k length subarray is 1, and this can be changed only when the ending index of the k length array is n. So this is an observation, but it doesn't help us much because I tried to think about some DP where first when we, so let's say we have the array 1 3 3 2 4. So the way, and k is equal to 3, to get this we need and initially 0 0 0 0 0. To get this we need one operation 1 2 3 0 0. To get this we need two operations 1 2 5 4 6. So these two have been taken care of, and then we need to take care of all these. But the problem with this is what I thought in the first go. But the problem with this is, how do we keep track of the, so if we do operations to get to make these two elements greater than bi, greater than b naught and greater than bn minus 1, these elements of the array would have changed. So how do we incorporate that into the DP? That is the question. So I couldn't deal with this. So another observation I had to make was, it is always optimal to fill from the end. The reason being, uh, let's say if we want this to be 42, one option is to start the segment from this element. That will take us 42 operations, while the other operation is from this element, start segment from this element. That will take us merely 42 by 3. See, if k is equal to 3, that is that will only take us 14 operations to uh, get to do this. And this greedy strategy always works. You can verify this. So this is a sample implementation of the greedy uh, strategy, where we start populating B from right to left, A from right to left. Yeah, so this is another observation, but the problem with this is, in the naive implementation, the time complexity is order of nk. The reason being, if let's say this is a1 to an, if we change this, all the k, so that is plus 1 plus 2 up to plus k. If this is done, all the elements from a minus n minus k plus 1 to an, all these are changed. So one from when we move from nth index to n minus 1th index, for n minus 1th index we'll have to uh, consider what change the nth index did to the n minus 1th index. So we have to somehow keep track of this, the change. So if we, in the naive implementation, we for every index I, we manually update all the indices, all the k indices uh, from I minus k plus 1 to I. That will take us order of nk time complexity. But we want to do better than this. The way we can do this is via an observation. let's say that this is the sample case where n is equal to 22, k is equal to 6. Let's say to get this the 22th element, to make this greater than equal to bi, we need x operations. Let's say if we do take x operations, after doing this element would have been incremented by 6x, this would have been incremented by 5x, and so on. This would have been incremented by x. Now when we go to 21th index, its value would have already been incremented by 5x. Now it wants to calculate y such that uh, 5x plus 6y plus 0, uh, this is the initial value, and after y operation this should be greater than equal to bi. It wants to find y. So yeah, this is the problem setup. Let's say now we are at we are currently at index 17, or let's say we are currently at index 19. We are keeping track of two things. One is the this quantity from the previous index. So for when we are at I is equal to 19, we'll keep track of this quantity. We'll call this current, and another quantity is sum of last k last operations. So that will, for I is equal to 19, it would be simply x plus y plus z. Okay. Now the way we, and take note that to calculate w, we w is basically this quantity, maximum of 0 comma ceil of b19 minus 3x plus 4y plus 5z by 6. 6 is basically k. Okay. And the reason we have 3x plus 5 4y plus 5z is because these three elements added this quantity to the uh, 19th index, which initially contained 0. Yeah, so w is this quantity. Now uh, how do we okay, how do we get this quantity is the question. We have current equal to 4x plus 5y plus 6z, and from 4x plus 5y plus 6z we want 3x plus 4y plus 5z. This can be written as current minus x plus y plus z. And what is x plus y plus z? It is simply the skl variable that we are maintaining. So current is equal to current minus skl. This is the relation we get. And once we have current, we can calculate w from this formula. Okay, so now we have w also. Once we have w, the current for when we reach index 18, we need to update current also and skl also. Current now becomes this quantity. So after uh, after this operation, current was uh, 3x plus 4y plus 5z. Now we need to add 6w also. So this is the operation by which we finally get current ready for the next step. This is the second update. So this is how we make current ready for the next step, and the way we make skl ready for the next step is skl minus equal to uh, let's say we store all these operations in a array called x of size n. So skl, the way we update is basically skl minus equal to x I plus k, and skl plus equal to w. This is the way we update skl. So having if we do maintain this array x of n elements and these two integer variables skl and cur, we are able to with order of n extra memory, we are able to get a time complexity of order n. The implementation in code is very similar to what I just explained. This is the given B array. This is updating current, finding xi, updating current. Now current is ready for the next index. This is updating answer, and this is updating slk, the variable slk, and this is just handling corner cases. Now this what we do here is uh, this logic was applicable only till this index. Why? Because after this index we just have one option, that is uh, we can only increment from we can only do operations in this segment if we want to increment any of these values. So the number of operations required to handle these elements basically is from handling all of them, these values would be updated. First, consider the changes made by these values to these elements, and then find the maximum number of operations required, uh, maximum number of operations of the form 1 to k, that is incrementing the segment 1 to k, required to make all the ai's greater than bi's in I range 1 to k. This is what we are doing here. Right. This is the answer.